Do you struggle to optimize forces for your mechanism designs? For example, consider a design of an oven door hinge. The door's forces must be low enough for users to open it with one hand while also high enough to ensure a sufficient seal when the door self closes. The reason you are struggling with your designs is most likely due to the impacts on forces from unexpected combinations of dimensional variations in a mechanism's components. These struggles can cost your organization millions of dollars in late-stage design changes, production delays, warranty recalls, and poor quality feedback from customers. Enventive's concept tolerance analysis software helps you meet force requirements right from the first design effort. Let's look at concept in action for a complex tolerance analysis of a candidate design for an oven door hinge. Our objective is to optimize functional requirements for the door, including a sealing force of 10 newtons in closed position, a blocking point to stay open at a 20-degree angle, and a sufficiently low user force during opening and closing to take into account statistical variations of these targets. We further specify minimum and maximum force values at ±5 newtons from the nominal target values. Each of the hinge components that you see can be imported from CAD files, as we did here, or easily sketched within concept. All types of tolerancing, using ISO or ASME standards, can be represented, such as for size, location, orientation, and form. In our hinge model, we calculate forces for the spring, roller, and cam contact, including friction, hinge joint contact, gravity, and the force required for a user to open the oven door. We can quickly compute the nominal values and statistical ranges for all these forces across the oven door's full range of motion. Here we can see the statistical results predicted by concept for the user force at the door handle compared to the minimum and maximum specifications. At 3 degrees, there is a high dispersion of values, which would lead to unacceptably high failure rates during production. Now we can focus on a detailed tolerance analysis at this critical 3-degree position to gain insights as to why the force levels are failing too often and how to resolve this problem. For our candidate design, you can see a very high failure rate, with only 43% of the hinges statistically predicted to meet force requirements. Now take a look in the lower part of the screen where Concept automatically calculates a list of all the contributors to the force variations along with their percentage of contribution. The main contributor is the profile tolerance of the hinge bracket roller surface, which contributes more than 47% to the overall variation. It turns out the bracket has a high sensitivity on the force levels due to a significant leverage effect caused by its geometry. Even the smallest geometric variations in the surface's profile can lead to large changes in the forces. With this insight, we can rapidly iterate design options to achieve an acceptable parts per million failure rate. A first option would be to tighten the tolerance ranges of the top contributors. Alternatively, a second option would be to redesign the bracket to reduce this sensitivity. Since it happens to be a lower cost option, we decide to choose option 2, which modifies the profile geometry of the bracket surface. This significantly reduces the sensitivity at the critical 3-degree angular position of the oven door, which leads to an acceptable failure rate. We can now recalculate the user handle forces over the entire range of the door opening angle and confirm that this new candidate mechanism design meets the minimum and maximum force requirements with an acceptable failure rate. Because of our analysis, we are confident in our hinge design and ready to send it to prototyping for testing before it goes to manufacturing. As you can see from the oven door hinge example, Enventive's concept tolerance analysis software has the tools you need to quickly create an optimal design, unlike traditional tolerance analysis tools, such as Excel spreadsheets, technical computing software like MATLAB, or 3-dimensional variational modelers. Enventive Concept enables mechanical designers to make the right tolerancing decisions by quickly evaluating the impacts on output design forces and moments due to variations in design geometry, material properties, friction, environmental temperature, or any other design attribute of concern. Would you like to learn more about how Enventive Concept can help you better design mechanisms? If so, please schedule a free demonstration using this link or by visiting our website at www.enventive.com.